Welcome to the Security Services UTM module. This module describes the basic purpose of Unified Threat Management, or UTM. It explains the working of anti-spam and antivirus. The module also describes the working of content filtering and web filtering. At the end of this module, you will be able to describe the basic purpose of UTM, explain how anti-spam works, explain how antivirus works, describe how content filtering works, explain how web filtering works. A network in today's market significantly contributes to the bottom line and is central to an organization's success. Of note are branch offices that normally include a relatively smaller number of computing resources when compared to central facilities or headquarters locations. Branch offices are typically located where customer interactions occur, which means there is an increased demand for supporting applications and assuring application performance. There is also an increased demand for security. General security vulnerabilities exist for every branch office network. These vulnerabilities include spam and phishing attacks, viruses, trojans, spyware-infected files, unapproved website access, and unapproved content. UTM security features are provided in the SRX series devices, enabling a business to protect itself from spam, viruses, worms, spyware, trojans, and malware. With UTM, you can implement a comprehensive set of security features that include anti-spam, antivirus, web filtering, and content filtering protection. These UTM features provide the ability to prevent threats in the SRX series devices before the threats enter the network. Note that UTM features are supported on all SRX series devices. This illustration explains how traffic is forwarded through the Junos OS flow module and at which steps UTM features are performed. The flow module is integrated into the forwarding path, where the hardware performs data plane packet forwarding. The flow module performs UTM features during the service's processing. Intelligent packet processing ensures that one single thread exists for packet flow processing associated with a single flow. Real-time processes enable the Junos OS to perform session-based packet forwarding. The Unified Threat Management daemon, or UTMD, performs the UTM features and protects the network from all types of attack. UTM traffic processing occurring within the Junos Flow module services is displayed. As traffic travels inbound on an interface of the SRX device, security policies process the traffic. If the security policy contains a UTM policy, a TCP proxy is used to process the matching traffic. The TCP proxy is used for both a TCP client and TCP server to terminate and originate a TCP session. The TCP proxy feeds the data stream to the application proxy. The application proxy contains a protocol parser, which extracts the application protocol information. The protocol information is evaluated by the various UTM feature modules. The SRX series provides comprehensive UTM features to protect against network-level and application-level attacks, and simultaneously stops content-based attacks. Click each feature to learn more. Custom objects are global parameters for all UTM features and are used to create object lists. These object lists contain the building blocks of IP addresses, domain names, email addresses, URL websites, and so on, used in UTM feature profiles. The majority of UTM settings are configured within feature profiles. The feature profile defines the operation of each UTM feature. For example, the antivirus feature profile settings control how a protocol is scanned and what the action will be when spam is identified. The UTM policy is the central point where all the different feature profiles of UTM are applied. Security policies reference the UTM policy so that as traffic is processed, the SRX device can offer the increased security that UTM provides. Spam consists of unwanted email messages. These email messages are usually sent by commercial, malicious, or fraudulent entities. Anti-spam is the ability to prevent spam before it enters the network. Anti-spam is one of several features that make up Juniper's UTM suite on the SRX series device. The anti-spam feature examines transmitted email messages. When the device detects a message deemed to be spam, it blocks the email message or tags the email message header or subject with a pre-programmed string. Note that the anti-spam feature is not meant to replace an existing anti-spam server on the network, but to complement it. The first method to discuss is server-based anti-spam. Server-based anti-spam means that the SRX device uses a third-party spam block list or SBL server to identify and eliminate spam. The SBL server uses a constantly updated IP-based spam blocking service. It stays current by constantly adding to its IP list of known spammers. The SRX device must meet a few requirements to use the SBL server. First, you must have a valid anti-spam license purchased and installed on the SRX series device. Also, you must have internet connectivity with the SBL server. The name for the third-party SBL server is predefined on the SRX device, and it is not configurable. Juniper has partnered with a particular vendor named Sophos to provide server-based anti-spam functionality. Domain Name System, or DNS, must be configured to access the SBL server. A name server entry must be properly defined and working on the SRX device. The SRX device performs the SBL lookups using DNS. The SBL lookups are performed against the IP address of the email sender or relaying agent. The DNS server then forwards each request to the SBL server, which returns a DNS response to the SRX device. The SRX device examines the DNS response to determine if the email sender is a spammer. This process automatically occurs when inbound or outbound email traverses the SRX series device. The second method of anti-spam filtering is the use of local lists. This method allows you to manually add an IP address, domain name, or email address to whitelists and blacklists. The SRX device stores and enforces these lists locally. No license is required for local list anti-spam filtering. The SRX device follows a specific order for checking spam. The device first checks incoming email against local whitelists and blacklists. If no match exists on either of these lists, the SRX device queries the SBL server for a match. If a match exists on any of these lists, the SRX device takes action, depending upon which list was matched, and either blocks or tags the message. When configuring the local lists, you should know how the SRX device searches the lists. The sender's IP address is searched first on the whitelist, then the blacklist, and then the SBL server. If no matching IP address is found, the device searches for the sender's domain name on the whitelist, and then the blacklist. If no matching domain name is found, the device searches for the sender's email address on the whitelist first, and then the blacklist. On either list, if multiple domain suffixes are configured, the SRX device matches against the longest suffix. For example, if the sender's email address has a domain name aaa.bbb.ccc, the SRX device looks to match aaa.bbb.ccc. If no match is found, it tries to match bbb.ccc, then CCC. The SRX device cannot do a partial match against IP addresses. Once a match occurs on a list, no more matching is processed. End users use SMTP to send outbound email, but they do not use SMTP to receive email. In the diagram displayed, User 1 sends an email to User 2. The arrows show the path of the email message. SMTP is used to send User 1's email message to their local email server. SMTP is again used to relay the message across the Internet to User 2's local email server. After User 2's email server receives the inbound email message, the client connection between User 2 and their local email server synchronizes through either Post Office Protocol 3 or POP3 or Internet Message Access Protocol or IMAP. This distinction is important because the anti-spam feature supports filtering only on SMTP. It does not support anti-spam filtering on POP3 nor IMAP. Identifying spam means identifying the senders of spam email. The SBL server filters on an IP-based blacklist, and it considers IP addresses included in the lists to be invalid addresses for mail servers. Criteria must be met to list an email server's IP address as spam. The SBL criteria to determine spam includes running an open relay service, running an open proxy of various kinds, zombie hosts, dynamic IP range, which will unlikely host a mail server, and a confirmed spam source, which are known IPs owned by spammers. When no positive identification exists for spam on an email message, the email message passes normally. Once the SRX device identifies spam, it either blocks or tags the email message. Blocked spam is dropped at either the connection level or email level. At the connection level, when the SMTP sender is identified as a spam sender based on its IP address or domain name, the SMTP connection is rejected. An error message with a corresponding SMTP error code is sent to close the connection. At the email level, when the SMTP sender is identified as a spam sender based on its email address, the email is rejected. An error message with a corresponding SMTP error code is sent back to the sender. If the SRX device tags spam at the connection level based on its IP address or domain name, it tags all emails on the connection. Otherwise, if the SRX device tags spam at the email level, it tags just the individual email message. The SRX device generates a log message each time it identifies a spam message. The log message contains information about the spam email sender, the type of matching spam filter, and what action the SRX device took. To prevent or reduce the volume of spam messages you receive, you must configure custom objects, an anti-spam profile, and a UTM policy. If you are using local list spam filtering, you must configure whitelists and blacklists using custom objects. If you are using only server-based spam filtering, you do not have to configure the local lists. The anti-spam feature profile is where you apply any local lists that are configured. The feature profile also includes the configuration for the default spam action. Note that when you configure the anti-spam profile, you must either enable or disable the SBL server. Next, you create a UTM policy that references the anti-spam feature profile. Finally, you assign the UTM policy to a security policy. The configuration for UTM custom objects for anti-spam is displayed. Under the Security Services, UTM Custom Objects section, you configure URL patterns that are used for local whitelists and blacklists. Remember the matching order of the entries, by IP address, domain name, then email address. The URL patterns you define are referenced in anti-spam feature profiles. The anti-spam default configuration enables you to select the whitelists, blacklists, and default settings for use with the anti-spam feature. Some of these default values, such as spam actions, tag strings, and enabling or disabling the use of the SBL server, can be overridden using a feature profile. After giving the profile a name, AS-Profile1, in this example, you can specify whether to use the SBL server. If you are not going to use the SBL server, select No. You must configure No SBL server if you are only going to use local list filtering. Next, you specify the default action, whether it is tag subject, block email, or tag header. If you are using the tag options, specify a custom tag string. You can specify only one tagging action. The example demonstrates how to configure the UTM anti-spam policy. You choose the name for the UTM policy. In this example, the policy is named Anti-Spam. Then, using the Anti-Spam Profiles tab, you specify the SMTP feature profile to use. In this case, the profile is named AS Profile 1. This profile is the feature profile created in the previous screen. Now you must apply the UTM policy to the appropriate security policy. Now you must apply the UTM policy to the appropriate security policy using the Edit Advanced Security option. Use the UTM drop-down menu to select the previously configured anti-spam UTM policy as demonstrated in the example. Click OK and commit your changes. SMTP traffic matching this security policy will be analyzed for spam. The example demonstrates JWeb monitoring of the anti-spam feature. In JWeb monitor mode, navigate to Security Services, UTM, Anti-Spam to verify and monitor anti-spam operation on an SRX device. The output shows DNS settings and how many emails are scanned, tagged, or dropped. The example demonstrates viewing the anti-spam event log on an SRX platform using the JWeb interface. In JWeb monitor mode, navigate to the Events Anti-Spam base to view log output. A virus is executable code that infects or attaches itself to other executable code to reproduce itself. Malicious viruses erase files, lock up and host systems, or otherwise interfere with network operation. Other viruses merely infect files and overwhelm the target host or network with bogus data. Additional virus-related threats include Trojans, rootkits, and other types of malicious code. Viruses are usually spread by attaching themselves as files or scripts inside protocol traffic. Antivirus is an established part of the UTM suite on the Junos OS and is an important part of any enterprise network security strategy. The antivirus feature of the SRX series device prevents viruses at the gateway before they enter the network. If a virus is detected, the file is dropped, and the originator of the traffic is notified. Antivirus scanning is a separately licensed subscription service. Starting in Junos 18.4R1, SRX series devices support Avira on-device antivirus scanning. Local antivirus scanning minimizes processing delays because the pattern database is locally stored and the scan engine is on-device. Avira protects your system from viruses, Trojans, rootkits, and other types of malicious code. The Avira engine scans data by accessing a local copy of the virus pattern database. It provides a full file-based antivirus scanning function that is available through a separately licensed subscription service. If your antivirus license key expires, you can continue to use the locally stored signatures without any updates. The Sophos virus pattern and malware database is located on external servers maintained by Sophos. There is no need to download and maintain large pattern databases on the Juniper device. The Sophos antivirus scanner uses a local internal scanner library cache to maintain query responses from the server to improve lookup performance. Queries are performed using the DNS protocol. Because a significant amount of traffic processed by the SRX is HTTP-based, Uniform Resource Identifier or URI checking is used to effectively prevent malicious content from reaching the endpoint client or server. The checks performed for HTTP traffic are URI lookup, true file type detection, and file checksum lookup. The application layer protocols that are supported are HTTP, FTP, SMTP, POP3, and IMAP. Sophos Antivirus has the following main features. Click each feature to learn more. The example demonstrates Sophos Live anti-malware protection. When the SRX antivirus module parses traffic, it can identify file types that are not considered harmful and should not be scanned. HTTP MIME headers and URL information can be used to obtain information about the file type being carried. The URL whitelist specifies traffic that can bypass antivirus scanning. The SRX device also uses MIME types to decide which traffic can bypass antivirus scanning. The example shows the order of HTTP processing with regard to antivirus scanning. URL whitelists are matched against first, followed by MIME whitelists. If no match occurs on either whitelist, the antivirus feature profile settings are followed for virus scanning. The URL and MIME whitelists are only valid for HTTP traffic. When the scan engine detects a virus, the file is blocked. Notification options inform users of detected viruses. Different notification types are available. One option is the notification type message. When content is blocked with the notification type message, the application client still gets a successful response code, but with modified content containing a warning message. The warning message can be custom defined. With the notification type protocol-only message, a protocol specifier error code might be returned to the client so that the client knows something happened, rather than assuming that the protocol transfer succeeded. For HTTP and FTP traffic, notifications are piggybacked in the protocols. For example, if a virus is found while doing an HTTP request, users will see a custom error message on the page they are trying to access. Email notifications for SMTP, IMAP, and POP3 protocols generate an error mail message, notifying the mail recipient and optionally the sender of the offending mail. 3 different settings exist for email notifications: virus detection or notify mail sender, fallback block or notify mail sender, and fallback non-block or notify mail recipient. Note that fallback options specify the actions to take when traffic cannot be scanned. The fallback actions are to either block or log and permit. Click each setting to learn more. Using UTM custom objects, you can configure URL patterns and URL categories. The example shows the configuration for the URL pattern named whitelist and a URL category named URL whitelist. The URL pattern name defines the pattern list name, and the URL pattern value contains the entries for URLs that bypass antivirus scanning. The URL pattern is added to a custom URL category. The MIME whitelist consists of one or many MIME type entries. The MIME entry is case insensitive. If the MIME entry ends with a / character, a prefix match is used. Otherwise, exact match is used. 2 types of MIME lists exist: a MIME whitelist and a MIME exception list. The MIME whitelist is used for bypassing antivirus scanning. The MIME exception list is used for excluding some MIME types from the MIME whitelist. For example, If the MIME whitelist has video/configured and the exception list has video/X shockwave flash configured, traffic with MIME type video/bypasses antivirus scanning, but traffic with MIME type video/X shockwave flash does not bypass antivirus scanning. Use the Security Services (UTM) default configuration antivirus options to choose the whitelists that you previously configured and to configure default antivirus scan options. Sophos engine options enable you to configure timeout options, DNS settings, notification, and fallback settings. The fallback options are taken when traffic is unable to be scanned. All fallback options have an action of either block or log and permit. The notification options can be configured for fallback block, fallback non-block, or virus detection. You can configure a custom notification message for all three options. The example demonstrates selecting Avira as the antivirus engine. Set parameters such as the MIME whitelist and pattern file update interval. The load flavor option determines the number of processor cores dedicated to antivirus scanning. The options are heavy or light. The default is light. Changing this option requires a reboot of the platform. Navigate to Security Services, UTM, Antivirus to create antivirus feature profiles. Antivirus feature profiles enable you to configure options not available in UTM feature defaults. Feature profiles are attached to antivirus UTM policies. UTM policies control which protocol traffic is sent to the antivirus scanning engine. The UTM policy displayed on the screen is named AV Policy 1 and has the antivirus profile AV Profile 1 applied for HTTP, FTP, SMTP, POP3, and IMAP traffic. Therefore, any type of traffic matching a security policy where the UTM policy is applied is processed by the antivirus module and follows the settings defined in the antivirus profile. The example shows the UTM policy AV Policy 1 being applied to a security policy. Matching traffic is forwarded to the antivirus module for processing. To monitor AV status on the device from JWeb Monitor mode, navigate to Security Services, UTM, Antivirus. The output displays the update server, the pattern update status, and the last result. If the pattern update is successful, the last result shows that either a new database has been loaded or that the SRX device already has the latest database. When the pattern update is successful, the scan engine is ready. The Statistics section displays antivirus statistics for connections, including total files, clean files, and the number of threats detected. It also shows statistics for traffic that has matched any of the fallback options. Content filtering permits or blocks traffic based on the following parameters. Click each parameter to learn more. You will now look at how HTTP, FTP, and mail protocols support content filtering in detail. Click each protocol to learn more. A message embedded in the protocol can be sent to the user, or an email message can be sent. In both cases, the content of the message is configured by the administrator. A content filter must coincide with a list of custom objects, which is a list of objects you would like to allow or block. The one exception is with HTTP traffic, which can be configured to block content directly under the content filter. This example displays the configuration options available for custom objects and content filtering. Custom objects options have the following configuration options. Click each option to learn more. Content filtering default options enable you to select the permit and block lists for different content types and to define notification settings. Content filtering filter profiles enable you to override default content filter settings. Permitted and blocked content types and notification settings can be configured. The filter profile is combined with a UTM content filtering policy. After you have created a content filtering profile, you create a UTM policy and apply the content filtering profile to the appropriate traffic you are filtering. The content filtering profile can be applied to multiple protocols. The final step is to apply the UTM policy to the appropriate security policy. The final step is combining the content filtering UTM policy with a security policy. The example demonstrates applying the Content Filter 1 UTM policy using the Security Policy Advanced Security Settings. Switch to JWeb Monitor mode and navigate to Security Settings, UTM, Content Filtering to view content filtering statistics. Web filtering or URL filtering provides the ability to permit or deny access to specific URLs based on the category to which they belong. The web filter intercepts HTTP requests, and a decision is then made with the HTTP request on an external server or Websense, or on the SRX device, whitelist or blacklist, to permit or block the request. Once traffic has been blocked, the client can receive a custom message in the web browser. The three supported deployment options are Juniper Enhanced, Websense, and Local Lists. Click each option to learn more. The Websense Redirect solution does not require a separate Juniper license, but utilizes a local database, which must be purchased separately from Websense. The SRX device redirects the URL to the local Websense server. The Websense server contains both the category database and the web filtering policies. The Websense server then compares the URL against its database and returns the result according to its configured policy. The response is then forwarded to the SRX device, indicating whether the URL is allowed or denied. This solution has the advantage of minimizing processing delays because the database is locally stored. The disadvantages include an administrator to keep the database current and multiple servers if you want redundancy. You can also configure custom URL categories, which can be included in blacklists and whitelists that are evaluated on the SRX device. All URLs for each category in a blacklist are denied, while all URLs for each category in a whitelist are permitted. The processing order is as follows. A new URL is first compared to the blacklist URLs. If a match is found, the traffic is dropped without any further processing. Second, if no match is found, the URL is evaluated against the whitelist, where traffic is allowed if a match is found. Third, if no user-defined category results in a match, processing continues either by surf control or Websense. Enhanced web filtering uses an Internet Websense server that stores a database of more than 95 predefined categories and associated site reputation information. The enhanced web filtering option requires the purchase of a Juniper web filtering license. Enhanced web filtering intercepts HTTP and HTTPS requests and sends the HTTP URL or the HTTPS source IP to the Websense Threat Seeker Cloud or TSC server. The TSC server categorizes the URL into one of the predefined categories and obtains site reputation information. The TSC server returns the URL category and the site reputation information to the SRX device. The SRX device determines if it can permit or block the request based on the information provided by the TSC and the feature profile configuration. Enhanced web filtering supports the following HTTP methods. Local web filtering by default permits all URLs. Therefore, a URL pattern to allow URLs is not needed. You only need to configure a whitelist if you configure the default action to block. URL patterns are combined with a URL category that web filtering uses for blacklists and whitelists. Web filtering default options enable you to specify a blacklist and whitelist. The example shows the WF whitelist selected for the URL whitelist. Web filtering feature profiles determine the type of web filtering used by the SRX platform. Profile type options include Websense Redirect, Juniper Local, and Juniper Enhanced. Feature profiles also determine the default action, permit, login permit, or block, and notification options. Website reputation options enable URLs to be permitted or blocked based on one of 5 classification options. The Category tab enables administrators to control access to websites based on the type of hosted content. The web filtering profile must be applied to a UTM policy, and the UTM policy must be applied to the appropriate security policy. The example illustrates where the web filtering profile is applied to the UTM policy. The example demonstrates the web filtering UTM policy applied to the security policy. JWeb Monitor Mode displays the results of your web filtering configuration. Counters are maintained, giving you a granular view of how many times a URL was permitted or blocked. Welcome to the Lab section of this module. You have reached the end of this module. In this module, you learned to describe the basic purpose of UTM, explain how anti-spam works, explain how antivirus works, describe how content filtering works, explain how web filtering works.